Hi everyone, it's Math with AUB. I have selected some properties of number system that are mostly asked in the MCQs type examination, and mostly students are blind to these facts. They ignore these tiny things, but they are wonderful, especially in modern mathematics and higher research. So without wasting time, let's see. Number one is the famous definition of a rational number. A rational number's definition is x is equal to p over q, where q doesn't be 0, pq both belongs to z. Z means integers, 0, plus minus 1, plus minus 2, and so on. That's the definition of rational number. A number that can be written in the form of p over q, where pq both belongs to z integers, they are also relatively prime, and q never be 0. Q never be 0. P and q can take any numbers from the integers with the exception that q never be 0, because division with 0 is not allowed. Division with 0 is not allowed. That is the famous definition of a rational number. That's the famous definition of rational numbers. And rational numbers are mostly denoted by q. While on the other hand, irrational number is written in the this form x doesn't be represented by p over q form, where x such that x is equal to p over q. If I introduce does not like this, it is the definition of irrational number. That's definition of irrational number. Irrational number. Another good MCQs on connecting rational and irrational. Their intersection is always null set. There is nothing common between rational and irrational. There is nothing common between rational and irrational number. They are mutually disjoint. They are mutually disjoint. Mutually disjoint means their intersection is null set. Their intersection is null set. One more fact: their union represents the real numbers. Their union results in real numbers. That their union results in union of rational numbers, irrational numbers. If we combine rational and irrational together, they will become real numbers. They will become real numbers, and it is a fit definition for partition or cell. Partition or cell. They are also called rational and irrational numbers, or cells for real number, or cells for real number. Cells for real number. Imaginary number, any number having iota, we are familiar, and iota is equal to -1. So it is not a complex number. What about index number? It is a statistical term used in statistics to measure the change of the price over time. To measure the change in price over the time of any substance or quantity, this is known as index number. So irrational number is the right option in that case. Moving one step further, prime number, a number that has exactly two divisors, is known as rational number. These are rational number: 2, 3, 5, 7, 11, 13, 11, 13, 17, 19, 23, 29, 31, 37, 41, and so on. These are known as prime numbers. So if n is any prime, then it remains an irrational number. Assert, because factors of prime numbers are not possible. Factors of prime numbers are not possible. Factors of prime numbers are not possible. Any prime number in the root, results in irrational number. Results in irrational number in that case. D option is missing. Let me write for you. It is an irrational number. So it is irrational number. If n is a prime, then it is irrational number. Another same type of MCQ is present like this, and where they mention n is a perfect square. N is a perfect square. If n is perfect square, then it is root, under root represents a rational number. It represents a rational number if n is perfect square. Why? Look, take any perfect square: 1, 4, 9, 16, 25, 36, or any quantity. Their root is possible, their root is positible. They all result in integer. 1 upon 1 I can write. 4 means 2. 2 upon 1 is also a rational number. 9 means 3. 3 upon 1 is a rational number. If n is a perfect square, root n represents a rational number. If n is prime, then under root n represents an irrational number. In that case, irrational number, I have included the D option. Somebody has missed. Okay. Pi pi is our famous irrational number. Pi is our famous irrational number having value approximately equal to 22 over 7 or 3.1459. Along with pi, there is another humongous irrational number, very Euler E 2.7 having value 2.71828. Its Euler number written as Euler, pronounced as Euler number. Okay, that's, and what about definition of pi? Definition of pi is circumference divided by diameter. Definition of pi is circumference over diameter. Circumference is given by 2 pi r and diameter is double of radius. 2r cancelled pi. Whatever the circle's radius is, whatever is the radius of the circle, the ratio of circumference and diameter is known as pi. It always results in pi, and it is a magic ratio, and it's a magic ratio pi. That's the definition of pi. That's definition of pi. Moving towards question number 4. Every non-repeating and non-terminating, neither repeating, non-terminating, neither recurring, non-repeating, repeating, non-terminating is known as irrational number. Is known as irrational number. That is definition of irrational number. Neither recurring nor terminating. Neither recurring nor terminating. Neither recurring nor terminating. Neither recurring nor terminating. That is definition of irrational number. Irrational. On the other hand, if any decimal is repeating or recurring, it is rational. If it is terminating, it is rational. Let me explain to you. Here is another example. A decimal which has only finite number of decimal. Finite means terminating decimal. Terminating decimal. Terminating decimal means finite means terminating. Terminating decimal represents a rational number. Always represents a rational number. Look, the number 1 is not prime. Mostly 1 is confused with prime. 1 is not prime. 1 is not prime. Mark these facts. 1 is not prime. 1 is not prime. 2 is only even 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 prime. The rest primes are odd. 3, 5, 7, 11, 13, 17, they are all odd. 1 is not prime. 1 is not prime. 2 is only even prime. 2 is only even prime. The rest primes are odd. So in that case, the number 1 is an odd number, odd integer. Good concept. Identity with respect to addition. Identity with respect to addition. Additive identity. 0 is additive identity. 0 is additive identity. 0 is additive identity. Identity means neutral elements. 0 can be added in any number to no effect. 0 can be added to any number with no effect. Such type of numbers are known as neutral elements. In case of addition, 0 is the neutral element or identity element. 0 is additive identity. 0 is additive identity. 0 is additive identity. On the other hand, there is a question arises, what about multiplication? Multiplicative identity is 1. Multiplicative identity is 1. 1 can be multiplied to anyone with no effect. 1 can be multiplied to anything with no effect. So under addition, identity is 0. Under addition, identity is 0. Under multiplication, identity is 1. Identity is 1. Identity is 1. It's a famous property. Every element, every real number is equal to itself. Every real number is equal to itself. This property is known as reflexive. This property is known as reflexive. I can also manage this reflexive, symmetric, transitive and law of trichotomy in our next video. It's my tiny effort to you guys to explain to you some number system that is mostly asked in MCQs type questions, and it is a surprise for students like a bouncer or York. You next time you are going to negotiate these things very elegantly and easily. It's my tiny effort to you guys. It's all by itself. Next.